Okay, so I think that my contributions really have been to the dimensions of strategy, ecological strategy, across plants. That is, things that they all do in common, but they vary quantitatively in how they do it. And I can give 3 examples, perhaps, of what those dimensions are like. So one is the dimension from producing very many very small seeds, not very well provisioned, and each with a low chance of survival, to producing few large but very heavily provisioned things. And lots of other things, the method of dispersal you use and so forth, are correlated with that. Second is what has come to be known as leaf economics, the leaf economic spectrum. And this is a spectrum from building your leaf area, which captures the light for plants very cheaply. So it is very profitable. You capture a lot of light per unit of investment, but the leaf does not live very long. So the revenue stream does not persist for a long time. And at the other end of the spectrum, you have species which build relatively expensive leaf area with a low rate of return per week, but a revenue stream that lasts for a long time. And thirdly, there is a spectrum from capturing carbon dioxide by using a lot of nitrogen in carbon dioxide capturing proteins, but not so much water. At the other extreme, using not so much nitrogen in those proteins, but more water. And again, you find a variation in this across the world and between different plant species. That's exactly right. There is a very close relationship, and we use the methods and the ideas of economics, particularly microeconomics, the economics of firms, in dealing with plants. And there are very good reasons for this, because they are firms, they are small operations, they acquire resources to make a product. And if they don't do that efficiently and make a profit on their carbon budget, then the lineage of their DNA goes out of business. Actually, I would say that most of economics applies better to plants than it does to humans. You don't have big monopolies. It's not possible for plants to go to the capital city and negotiate for better tax rates. It's not possible for them to insure against risks. They just have to use resources, put them together, run an efficient productive process, and do that more efficiently than their competitors. Otherwise, their DNA goes out of business. What my research does is it tries to understand species in a more systematic way. And ecosystems are made up of species. Ecosystems are a machine where the cogs and the levers and the connecting rods are species. And so being able to understand how those pieces of machinery work is a prerequisite for being able to forecast the consequences of any kind of change. I've not been directly involved in using this to forecast those kinds of change. My work is at a more basic, how do the pieces of machinery work level. So as far as what we should do about it, we should simply stop burning fossil fuels. Actually, we should have stopped burning fossil fuels 30 years ago, when there were already many reports explaining what was going to happen if we didn't, and pointing out that it was urgent. And of course, both the strength of the evidence and the urgency of the matter has only become greater since that time. As far as what loss of species means, one thing that's very important that it means to me is that species really are heritage. So on average, a species will have 1 million years of history separate from its closest relative sister species. Now, a million years is a long time. A million years is 200 times more heritage than the pyramids of Egypt. And through all that time, so each species we have on Earth is this very deep time heritage. And we know that through all that time, it has been solving problems that are somehow unique to it. But mostly we don't know the detail of exactly what those problems were. So when you lose species, it's like burning libraries. It's like bulldozing important monuments. It's all of those things. Only I would say more severe. It's the deep history of life on Earth. And we stand to lose really large proportions of species over the next 100 years.